So hello everyone, a very good evening to each and everyone out there, and I welcome you all to this amazing platform of PW Gulf, and this is your math educator Shivangi Rajput. In this particular video, we are going to cover our quadrilaterals in one single shot, all the theorems and question and explanation of all the concepts that are involved. In this particular chapter will be conducted in this particular ultimate recap. So let's begin with what is the topics to be covered, what is our today's target. So the very first thing that we will be starting with a basic introduction to the chapter's name, that what are quadrilaterals. After that, we are going to discuss about the angle sum property of quadrilateral, types of quadrilateral, properties of parallelogram, midpoint theorem, and some important questions regarding all the topics that we are going to cover today. So let's start with it. The very first thing that we have to talk about in this particular video is what? The name of the chapter, quadrilaterals. So as we are already aware about that quad over here means four. So any closed figure that is made up of four sides is known as what? Is known as our quadrilateral. So one thing that is very important is what are quadrilaterals? Any four-sided figure. Now, in any four-sided figure, when I talk about, it includes square because it has four sides. It includes your parallelogram, it has four sides. After that, it includes your rectangle, your trapezium, and all the other figures that comprises of your four sides. Now, along with these four sides, we have what? Four angles, four vertices, four edges, and everything. So, of course, a relationship between each and every one of them is going to be discussed in this particular video. So, the next topic that we have is angle sum property of a quadrilateral. Now, before this, we are already aware about the angle sum properties of triangle. Now, what is angle sum property of triangle, student? That the sum of all the three angles of the triangle leads to what? All the triangle leads to 180. Now, over here what we have is the sum of all the four angles of a quadrilateral give us a sum of 360 degree. Now, as you can see in this figure, this is any four-sided figure A, B, C and D. We have constructed one diagonal, that is A to C. And when we have constructed this diagonal, we can clearly see that this four-sided figure is divided into two triangles, right? One is triangle ADC, students, and the other one is ABC. We are already aware about that the angle sum property of a triangle is 180 degree. That is, the sum of all the angles of this triangle will be equal to 180 degree. The next we have is the angle sum property of this triangle. That is, sum of all the angles of this down triangle is also equals to 180 degree. So, the sum will be resulting 360 degrees. So, that's why we say that the angle sum property of any quadrilateral that we talk about gives us what? 360 degree, that is 180 degrees plus 180 degrees. Right? The next thing that we have over here is types of quadrilaterals. Now, in this chapter, there are various number of types of quadrilaterals that we are going to talk about. The very first thing is the very basic one that we have always been studying about, a square. What all the properties of square that we are, already aware of? First of all sides are equal, right? So, in a square, what we have, all sides equal. After that, we have each angle as 90 degree, right? Each angle is equivalent to 90 degree. After that, we also know that the diagonals of a square are equal, right? Diagonals are equal. So, when we talk about diagonals are equal, if I join this point to this point, this point to this point, so both of these will be equal in length. That is, sides are equal, each angle is 90 and the diagonals of a square are equal. The next figure that we have over here is a rectangle, right? Now, in rectangle, we know what? That the opposite sides are equal. Right? Each angle is 90 degree and the diagonals in the case of your rectangles are also equal. Right? So, that's why we say a square can be considered as a rectangle because in square we have all sides equal, in rectangle we have opposite sides equal, right? So in square also, if all sides are equal, that means opposite sides are also equal. So we can say that all squares are rectangle, but all rectangles are not square. So let's talk about the next type of quadrilateral. Again, a four-sided figure. This is a kite, right? So basically, kite over here has what? The adjacent sides of a kite are equal, right? What we have that the adjacent sides of the kites are equal. So this is the property of kite. The next thing that we have is a diamond, right? In diamond, what we have? In diamond, we have all the sides of the diamond are equal, right? But of course, the angle of you are like aware of square also. In square also, all the sides are equal, right? In diamond also, all the sides are equal. But what is the difference then? The difference over here lies in what? That particularly in a diamond, the angles are not of 90 degree, but in square, they are. The next thing that we have is a rhombus. Now in rhombus, students, all the sides are again equal, right? But again, what makes it different from the square is what? That since even if all the sides are equal, the angles are not 90 degree. There is one more property of rhombus, students, and what is that property? When we talk about one more property of rhombus, that includes that the diagonals, right? When we talk about the diagonal, students, the diagonal of a rhombus bisect each other at 90 degree. Now, what is the meaning of this word bisect, right? This word over here means splits into two equal parts. Splits into two equal parts. So this is the definition of bisect, that is splitting it into two equal parts. So when we talk about rhombus, this is one of the most important property of rhombus, that the diagonals of a rhombus first of all bisect each other at 90 degree. That means wherever they meet, they form the angle of 90 degree, and secondly they bisect each other. That means they split the diagonals into two equal parts, right? So by this we have different questions that are formed regarding the same concept. Now let's see the next type of quadrilateral that we have is a parallelogram. Now this is one of the most important figure in this particular chapter, as most of the proving and again midpoint theorem also includes a parallelogram. So most of the proving and all that thing will be done with the help of parallelogram. Now what are the properties of parallelogram? The very first thing, opposite sides are equal. In a parallelogram, opposite sides are equal. Then what we have is opposite angles are equal. Opposite angles are equal, right? Opposite sides are equal and parallel as well. Equal and parallel. Diagonals are not equal, but diagonals bisect each other. I hope that now everyone is clear about the word bisect. What does bisect means? So diagonal bisect each other, and the next thing that we have is adjacent angles are supplementary. That is, the adjacent angles gives a sum of 180 degree. Adjacent angles are supplementary. So these are the properties of a parallelogram, right? So this is very important to deal with. Now we have trapezoid, right? Or we can say trapezium. There is one difference, like in trapezoid, the non-parallel sides are equal. In trapezium, it is not such mandatory. The next thing that we have is trapezium. Of course, in trapezium, we have one parallel sides, one pair of sides as parallel, that is true. And the other are the non-parallel sides. The next that we have is a summation of all the shapes and properties that we have discussed. Let's quickly recall them. When we talked about square, the opposite sides are parallel, all sides are equal, and all angles are 90 degree. This is the properties of square. The next we have is a rhombus. Students, opposite sides are parallel, right? All sides are equal, opposite angles are equal, and diagonals bisect each other at 90 degree. When we talk about rectangle, opposite sides are parallel and equal, all angles are right angles. Then we talk about students parallelogram, opposite sides are parallel and equal, opposite angles are equal, adjacent angles are also supplementary, and then we have what diagonals bisect each other. Then we have trapezoid, one pair of opposite sides is parallel, then we have kite, two pair of adjacent sides are equal, one pair of opposite sides are equal. Then what we have, one diagonal bisect the other and diagonal intersect at right angle. So these are the properties. I hope the properties are clear, and now we are moving forward to the theorems that are related to this chapter. So the very first theorem that we have is a diagonal of a parallelogram divides it into two congruent triangles. Now what does this mean, students? If we have a parallelogram, right? If we have a parallelogram, and for suppose if I draw one diagonal, right? Supposingly I draw one diagonal of this parallelogram. So basically the diagonal, now we can see that this parallelogram now by the help of this diagonal is divided into two congruent triangles. Right, and these two congruent triangles, of course, how we can do it? First of all, if we have to prove it, this side will be equal to this side as opposite sides of the parallelogram are equal. This side will be equal to this side, again opposite sides of the parallelogram are equal, and this particular diagonal is common in both the triangles. So by triple S criteria or by SSS congruency criteria, we can say that these two triangles are congruent to each other. So this theorem is what? When one diagonal is drawn in a parallelogram, that means when two triangles are formed respectively, so those two triangles will always be congruent given that that figure is a parallelogram. The next thing that we have is in a parallelogram, opposite sides are equal. Now what do we have? That if we have a parallelogram, the opposite sides in the parallelogram are equal. So all these theorems are nothing but just some properties of the quadrilaterals that we have already discussed. This is just the proving of it, right? So the second theorem is in a parallelogram, the opposite sides are equal. Like for example, if we have any parallelogram in front of us, that is for example this. So in this parallelogram, students, this side will be equal to this side and this side will be equal to this side as they are the opposite sides of the parallelogram. The next we have is in each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So what they are saying that if we have a quadrilateral and it is not specified that it is a parallelogram, but what is given that the figure is a quadrilateral and opposite angles are equal. Since opposite, both pair of opposite angles will be equal, so what we can say that the figure so formed will always be a parallelogram. The next theorem that we have is in a parallelogram, opposite angles are equal, the converse of the previous theorem. Now we have if in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram again. All right. Now the next thing that we have is, okay, the diagonals of a parallelogram bisect each other. Again, one of the most important property of your parallelogram, students. If I draw one diagonal, if I draw another diagonal, they bisect each other means what? They split each other into two equal halves. So when we talk about the diagonals of a parallelogram bisect each other, that means they split both of them into two equal halves. I hope this thing is clear with everyone. Right, let's move forward. Over here we have the diagonals of a quadrilateral bisect each other, then it is a parallelogram. The converse of the previous theorem, right? What we have that if the diagonals bisect each other of any quadrilateral and it is not specified that that quadrilateral is what, a parallelogram, so we can clearly say that that figure that is formed will be a parallelogram. Okay, let's move to one of the question. It says, the angles of a quadrilateral are in the ratio 3:5:9:13. Now, what is given that there is a parallelogram, right? Sorry, there is a quadrilateral, any four-sided figure, right? This is a four-sided figure and the angles are specified as 3:5:9:13. Whenever ratio thing is given to us, we always add a constant multiplication to each and every one so that all the angles becomes 3x, 5x, 9x and 13x. Now we have to find all the four angles, students. For example, let this angle be 3x, this angle be 5x, this angle be 9x, and this angle be 13x. So basically we know that sum of all these angles, that is 3x plus 5x plus 9x plus 13x, will be equal to 360 degree. Why? Because we are already aware about that the sum of all the angles in a quadrilateral gives us what? 360 degree. Now what we have over here is 5 and 3. This will give us what? 8. 8 and 9 will simply give us 17, and 17 plus 13 will give us 30x is equals to 360. 0 and 0, 30. So basically the value of x comes out to be 13. Now we have to find all the angles of the quadrilateral, right? So this particular angle simply, students, will be equivalent to 3 into 13. This will be equivalent to 5 into 13. This will be equivalent to 9 into 13. And this will be equivalent to 13 into 13, as simple as that, right? So simply what we can say that this angle will give us what? 39 degrees. So this angle will be equal to simply what? 39 degrees. This angle will be equal to 65 degrees, as simple as that, right? I hope the part till here is clear with everyone. 13 into 13 will give us what? 169 degrees. As simple as that. And 9 into 13 will give us 117 degrees. So these are the 4 angles that we will be getting after our x comes out to be what? 13. I hope this thing is clear with everyone, right? Okay, so let's move forward to the next question. The next question says that ABCD is a rhombus, right? Show that diagonals AC bisects angle A as well as angle C, and diagonal BD bisects angle B as well as angle D. Like, first of all, what we have to do, we have to name this rhombus, right? Let us name this as A, B, C, D, and let us name the intersection part as E. So what we have to show, we have to say that show the diagonal AC bisects angle A as well as angle C, and then diagonal BD bisects angle B as well as angle D. This is what we have to show. First of all, let's take this triangle and this triangle, that is in triangle ABC, students, and in triangle ADC, right? How can we prove the congruency in these two triangles that we are having? First of all, AB is equals to AD, right? We have taken ABC. What we can say that AB is equals to AD because we know that all the sides of a rhombus are equal. Then we can say that BC is equals to DC. BC is equals to DC. Again, all the sides of the parallelogram are equal. And then we can say what? Simply that AC is equals to AC, which is common. For both of them, these are nothing but just sides of rhombus. And we are already aware about that all the sides of rhombus are equal. Right? The next thing that we can say is, now we have to say that angle A, that AC bisects angle A as well as angle C. So from this, we can say that triangle ABC is congruent to triangle ADC by triple S criteria, students, by SSS criteria. And now we can say that angle BAC will be equal to angle DAC by CPCT, that is the corresponding parts of congruent triangles. The next thing that we can say that angle BCA will be equal to angle DCA again by CPCT. Now, since in the figure we have already shown that this angle is equals to this angle and this angle is equals to this angle, so we can say that yes, this AC line has bisected angle A and angle C. Now, similarly, students, in the second part, what we can do is, we can now take this particular triangle and this particular triangle. Now again by triple S criteria, we can prove the congruency in these two. And after proving the congruency, we can say that this angle is equals to this angle and this angle is equals to this angle by CPCT. And once we have shown the angles are equal by CPCT, so we can say that BD also bisects angle B and angle D. So this is how these type of questions are supposed to be done, right? So this is what we have to do. The next part over here we have is ABCD is a parallelogram. So the figure that is available in front of you forms what? A parallelogram. And AP and CQ are perpendiculars from the vertices A and C on the diagonal BD. Show that triangle APB. Let us first of all mark it. Right? Which is triangle APB? This is triangle APB. Now let us mark the second triangle, that is triangle CQD. Now triangle CQD will become this one, right? This will be triangle CQD. This is Q. Now let us do this question. We have to prove the congruency in these two. We have to prove in the first part that APB is congruent to CQD. Now, the very first thing that is given to us is that ABCD is a parallelogram, students. Now, in your triangle APB and your triangle CQD. Now, what are the things that we can take in these two triangles to make them congruent, right? The very first thing that we can say is AB is equals to CD. We can say that AB is equals to DC. Why? We can say because opposite sides of a parallelogram. And we are aware about that opposite sides of a parallelogram are what? Opposite sides of the parallelogram are equal. The next thing that we have is in this particular part that see this angle PBA will be equivalent to this angle that is CDQ because these are alternate interior angles. How they are forming alternate interior angle, just see. This line is parallel to this line and this is the transversal, right? So this angle will be equal to this angle by your simply alternate interior angles. So angle, what we can say ABP will be equal to angle CDQ, right? And why we can say that? Because these are alternate interior angles and what all have we taken that AB is parallel to CD and your BD is transversal, right? So these are the things that we have taken. Now, next that we can say is since we know that AP and CQ are perpendiculars, if AP and CQ are perpendicular, that means what? That they are forming 90 degree, right? So we can say that angle APB is equal to angle CQD because 90 degree. So by angle side. So by angle side criteria, AAS congruency, both the triangles will be what? Congruent. I hope this thing is clear with everyone. Now the next thing they were asking in this question, there was a second part too. For example, what if they ask, show that AP is equals to CQ. Now what we can say that also, now if the part asks that AP is equals to CQ, how can we say that AP is equals to CQ? By simply CPCT, that is corresponding parts of congruent triangle. Now let's move forward to our midpoint theorem. Now this particular theorem is one of the most important segment, most important part in this particular chapter. Believe me, this particular midpoint theorem is the most important concept and its proving is majorly asked. So let's start with it. The theorem over here says what? First of all, understand the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Now what does this mean? Right? We have to firstly understand what does this mean. For example, students, if we have a triangle, you are given a triangle. Now, I say that this is a triangle A, B, and C. Right, I have given you a triangle ABC. Now, for the side AB, what? For the side AB, I have given you a point D, and this D is the midpoint of side AB. For the other side AC, I have again given a point E, and this E will be the midpoint of AC, right? D is the midpoint of AB, and E is the midpoint of AC. Now, if I'm about to join these two midpoints, right? If I join this point D to E, right? So, basically, we are just given a point D that is midpoint of AB and one point E that is the midpoint of AC, and we have joined, right? They have no relation with BC. But when we join these two midpoints of both these sides, so the line so formed, that is DE, will be parallel to the third side, students, that is over here in this case BC, and also be equal to half of it. So this is what midpoint theorem means, that if we have a triangle and for suppose D and E are the midpoints of sides AB and AC respectively, so when we will join this D and E, so this DE line so formed will be parallel to the third side and also will be equal to half of it. Alright, let's move forward and see the proving of this theorem. So, very first thing that we are given is a triangle, right? This triangle is A, B, and C, right? The next thing that we are given is that D is the midpoint of one side, E is the midpoint of the other side. Now, we have to join this and then we have to prove that D is parallel to BC. This is what we have to prove. So, first of all, we have to prove that D is parallel to BC and D is equals to half of BC. The next step that we are going to do in this particular case is a construction, students, right? So, we are over here constructing a line. Alright, so we are over here constructing a line, students, that is this. Let us name this as F and let's just join it. Alright, so this is the construction that we have done, that through C, we have drawn a line parallel. This CF line is parallel to AB, right? This CF line is parallel to AB and we have done the construction, right? So, let's start with the proving of this particular theorem. So, first of all, let us write down what is given to us, right? So, what is given to us, students, that D and E are the midpoints of AB and AC respectively, right? The next thing that we have given, that we are given is what? We have done a construction. Now, what is the construction that we have done? That from C, draw CF parallel to AB, right? This is the construction. Now, what we have to prove? So, at the end, what is our motive for this theorem is, we have to prove that DE parallel to BC and DE is also equals to half of BC. So, this is what we have to prove in this particular theorem. The very first motive for proving this theorem is take these two triangles. Which two triangles, students? Take these two triangles. One is ADE triangle and the other one is this CEF triangle. Now, in both of these triangles, you have to do what? Prove the congruency. Let's start with the proving. Right? So, firstly, what I have told you guys, take these two triangles, that is triangle DAE and your triangle CEF, right? FCE, sorry. Triangle FCE. So, these are the two triangles that we have taken. All right. So very first thing, students, what we can say is A is equals to EC. That this AE is equals to EC. That means this side is equals to this side. Why we can say that? Because E is midpoint of AC. What is E? E is the midpoint of AC, and since E is the midpoint, so we can say AE is equals to EC. The next thing that we are having, student, is C. Firstly, this side, this side. Now we can say that this angle will be equal to this angle. Why? Vertically opposite angles. That angle AED will be equal to angle AED, and we have CEF. Why we can say that? Because these are vertically opposite angles. Now the next thing that we are having over here is what? Now we can see that AB is parallel to CF, students. Right. See clearly this particular part, that AB is parallel to CF. If this whole AB is parallel to CF, so AD will be parallel to CF as well. And if AD is parallel to CF, I'm taking this as the transversal, so this angle will be equal to this angle, alternate interior angle. So we can say that angle DAE will be equal to angle FCE, taking what? AD parallel to CF by construction. This is what we have done by construction. And then we have our what? AC as transversal. We have AC as transversal. So now we can say that triangle DAE will be equal to triangle CEF by our angle side angle criteria, that is ASA criteria. Both the triangles will be congruent. Now what we can say? We can say now that D is equals to FE. We can say that D is equals to FE by CPCT, right? The corresponding parts of the congruent triangles. Right? What we can say that D is equals to FE. Also we can say that FC. That this FC is equals to AD. This FC is also equals to AD. We can say that by CPCT. Now let's move to the next part. Right? Now what is the next part over here, students? Just give me a second. All right. So what is the next part now that we have in this particular thing? So we have proved that CF is equals to AD. Right. We also know that CF is parallel to AD. Why? Because by CF is parallel to AB, so CF will be parallel to AD. This is very common. All right. See, we know that D is the midpoint of AB, students. So AD will be equal to BD. This is what we are aware of. We have side AB, and if D is the midpoint, so AD will be equals to BD. So that means we know that AD is equals to BD. Why? Because D is midpoint of AB. D is midpoint of AB. As simple as that. Now, in the very first thing, see, if CF is equals to AD and AD is equals to BD. So, from 1 and 2, what we can write by using these two statements, students, we can conclude that CF is also equals to BD. Now, listen to one part. If CF is parallel to AB, right, then CF is parallel to AD. So, CF will also be parallel to BD. Right. So, we can also say that CF is parallel to AB. So, CF will also be parallel to DB. All right. See, now CF is equals to BD and CF is parallel to BD. That means BCFD. Listen to me very carefully, students. What we are taking? We are taking this particular figure and we are trying to prove it a parallelogram. Now we have proved that CF is equals to BD. CF is parallel to BD. Since one pair of opposite sides are equal and parallel, so we can simply say that DFCB or BCFD is a parallelogram. As simple as that. And if BCFD is a parallelogram, so BC parallel to DF. Alright, this BC is parallel to DF, and if BC is parallel to DF, so DF. So BC will always be parallel to half of D, right? So BC will also be parallel to half of DF. And what is half of DF, students? Half of DF is your DE. Secondly, what we have in the next part, BC is equals to DF. Why? Because these are opposite sides of parallelogram. These are opposite sides of parallelogram. So BC, right, on the place of DF, I can write twice of DE, or in the place of DF, I can write DE plus EF, right? And DE is equals to FE or EF by CPCT, already proven. So on the place of this EF, I will be writing BC is equals to DE plus DE. That is equals to twice of DE. So BC is equals to twice of DE, or we can say that half of BC will be equals to DE. So these are the two things that we had to prove. So this is the proof, students. Have a look forward to it. I hope it is made easy enough for you to understand, right? Okay. Let's see the type of question that we will be having while solving it, right? So this is one type of question that we might face, that this is a triangle ABC. DE and F are respectively the midpoints of sides BC, AB and CA. Show that ABC is divided into 4 congruent triangles. So what we are given, that this DEF are the midpoints, very first thing, right? Since DF are the midpoints, so we can say that DF parallel to BC by midpoint theorem, and also DF is equals to half of BC. This is the first thing that we can do. Now we have to focus on this figure. DBEF. This is the figure that we have to focus upon. Now in this figure, what we have to show, we have to prove anyhow that this is a parallelogram, right? Now what we can do? Say DF, if DF is parallel to BC, students, so DF will be parallel to part of BC. If DF is parallel to BC, so DF will be parallel to a part of BC, that is BE. So DF will be parallel to BE as well, right? And since E is the midpoint of BC, so DF will be equals to BE, as E is midpoint. Right? Since one pair of opposite sides is equal and parallel, so we can say that DBEF is a parallelogram. So DBEF is a parallelogram. And as we have already learnt about a property of parallelogram, the diagonal splits it into 2 congruent triangles. So basically we can say that this triangle is congruent to this triangle. That is, triangle DBF congruent to your triangle DFE, right? As the diagonal of the parallelogram divides it into 2 congruent triangles. Now similarly, like students, likewise what we can do, now instead of these parallelogram, I can take this as a parallelogram. And now what I can say is, for suppose let me mark this as 1, 2, 3 and 4. Now right now I have proved that triangle 2 is congruent to triangle 1. Now when I take these 2 triangles, these parallelogram and these 2 triangles, I can say that triangle 1 is congruent to triangle 3. And if I take these 2, like for example, if I take this as a parallelogram, this, which one? Let me mark it again. For example, if I take this as a parallelogram, right? So this was my 1, 2, 3 and 4. Now from this I can say triangle 1 is congruent to triangle 4. Now see, triangle 1 is congruent to triangle 2, triangle 1 is congruent to triangle 3 and triangle 1 is also congruent to triangle 4. That means all these 4 triangles are congruent to each other. And if all these 4 triangles are congruent to each other, then this is what we had to prove, that the triangles that have joined and formed are congruent to each other. Let's move forward to one more question. Over here we have that ABCD is a quadrilateral in which PQRS are the midpoints of sides AB, BC, CD and DA. AC is a diagonal. Show that SR is parallel to AC and SR is half of AC. Right? S and R are the midpoints. The very first thing we have to imagine this as a triangle. Right? Now in this triangle, student, what is given? S and R are the midpoints. And by midpoint theorem, simple what you will write, by midpoint theorem, SR will be parallel to AC and SR will be equal to half of AC. This is what midpoint theorem teaches us. Right? As simple as that. The next part we have is prove that PQ is equivalent to QR. SR, sorry, not QR, that PQ is equivalent to your SR. Right. So when we have taken triangle DAC, right, when we took triangle DAC, in this S and R are midpoints, S and R were midpoints. So by midpoint theorem, what we did? So by midpoint theorem, we have proved that SR is parallel to AC and SR is equivalent to half of AC. Now when we take the other triangle, that is ABC. Now in triangle A, B and C, students, what do we have? That P and Q are the midpoints. P and Q are the midpoints. Right? So what we can say over here is that PQ is parallel to AC and PQ is half of AC. Now see, SR is also half of AC, PQ is also half of AC. So from these two we can say that SR is equivalent to PQ. This is what we had to prove. So these are just simple application of your midpoint theorem, and this was all about the quadrilaterals, the property and the proving of theorems, and especially the midpoint theorem and questions related to it. I hope that each and everything is clear with you people. If you have any doubt, feel free to leave it in the comments and we will surely be replying to you. Thank you so much, and let's meet in the next ultimate recap. Thank you.